good afternoon, or if you're possibly joining us from the West Coast, still good morning. This is Victoria Beal with the Ohio LTAP Center, and I would like to welcome you to part 3 of roadway drainage maintenance. And it's being provided through our partnership with the North Carolina LTAP Center, specifically Scott Tyson, who is going to be your instructor for the third part of this webinar series. And a couple of housekeeping items, and a few of you already are on your game here because you know that I'm going to ask you to look for the question box and the GoToWebinar panel and to please drop me a hi or hello so I know you found it. That is the way I would ask that you please respond, either with questions or with any comments you have throughout the webinar to questions that Scott might have for you. Additionally, I'd like to mention that in the handout section of the GoToWebinar panel, we do have available for you the slides from today's presentation. And I've uploaded flyers for 3 other webinars we have coming up. 2 of them actually are listed on one flyer, and it's tomorrow. I'm missing baseball season terribly, so we're doing a double header tomorrow. We've got our TIMS and GCAT webinar. This is our GIS crash analysis tool that we make available to local public agencies in Ohio to do their own crash mapping. And then TIMS, which is our transportation information mapping system. We also have 2 webinars that are coming up beginning of June. One is Ethics for Engineers, Jeopardy style, which our presenter is going to be Ted Green from the New Jersey LTAP Center. And then we have ins and outs of the OH1. The OH1 is our crash report here in Ohio. And for those of you who love data and love to get into the nitty-gritty of what's available that you can report out on and analyze and crunch the numbers with, that OH1 report webinar is going to be for you. Our person who's going to present on that is Derek Troyer, and he's just going to go through and explain to you everything that's possibly available on the OH1 and the different levels of information you're going to find in the system based on the level of crash severity. So with that, I'm done with the future webinars commercial, and I'm going to turn things over to Scott. You ready, Scott?
Yes, ma'am, I'm ready to go. Thank you.
Thanks.
Victoria, thank you so much for having me back for a third part and our final part of the roadway drainage maintenance webinar series. Thank you so much to everyone who is coming back and has been with us for the first 2 and coming back for the final one. If this is your first time, thank you for taking an hour out of your day as well to spend that with me. I want to give you your contact information one last time for you to take a look at. Go ahead and write it down if you would, screenshot it, take a picture of it. I am a resource. I am very happy to help anyone that reaches out. You can reach out to Victoria and she will get that information to me as well. Again, I would recommend not calling the office number. Again, I'm working from home like a whole lot of people are, so the email address is a much better way of getting a hold of me. So let's jump right into it. We ended our Thursday webinar talking about pipe maintenance, and I want to jump into geotextiles real quick. And this is kind of a reinforcement of what we've talked about. And again, this is basically roadway drainage maintenance. And when we've talked about geotextiles, the first 2 webinars, they give us a little bit of separation between the soil layers. We're going to talk about how they help us with our drainage, hopefully help prevent some erosion and give the foundations some much needed reinforcement. When we are using geotextiles, we typically use the non-woven geotextiles. That allows the water to get through the geotextile instead of pooling. And we do also use our geotextiles when we're setting out our surface drains as well. Give you an idea of what I'm talking about, we have our pavement layer right here. We have our aggregate layer, and then we have our subgrade, our soil, the base from which we're working. And if you'll notice, we place the geotextile material in between the aggregate and in between the subgrade. And we talked a little about this, I believe, in the first webinar. Let me show this to you. You can see without a fabric in there that there is no way to separate the rock from the soil. And so when a tire goes over that area, it's going to press the rock down. It's going to press the soil down. That's not very good compaction, which we spent a lot of time at the end of Thursday's webinar talking about. But notice when we put the geotextile between the soil, between the rock. It gives a layer of extra protection there that allows the two ingredients to stay separate, and it also gives us a much stronger base to work from. Notice there's a whole lot of air voids and area between the rocks and the soil right there, but with the fabric, it allows the soil to stay where it is. It allows the rock to stay where it is, and we are able to get those air voids out, hopefully allowing for a much smoother ride for the motorist. But even more so than that, we're allowing for them to have the opportunity to have that road last a whole lot longer, so we're not having to dip into taxpayer funds. When we talk about shoulder drains, which we mentioned 2 slides previously, I want to give you an idea of what that might look like. You see we have the pavement on top as it was previously shown. We've got some soil out here. We would represent a fabric, a geosynthetic, right in there, geotextile. Again, we have some aggregate, and notice we've got our pipe right there. And what we want to make sure, and this picture doesn't do it maybe to the level that I would like, we want to get as much of the air voids out of that area as we can to make sure we've got good compaction. What we don't want to have happen is as vehicles, especially the larger vehicles, the heavier vehicles, go over our pavement, that gets pressed down, this gets pressed down. You don't want a ton of air voids in there. We want to make sure we get that out as much as possible. But this is our spot. This is where we want the water to flow through. And if we don't have good compaction around it, that pipe is liable to give. It may sink, it may roll to the side or a little bit. And again, we're not going to have water flowing the way that we want it to. And of course, it's not exactly to scale. Our pipes would be larger than that. But this is how it should look on a subsurface or a shoulder drain. And we're going to spend a lot of time today talking about when it's raining, what we're looking for. It's really important to check your outlet pipes when it's raining to make sure they are fully flowing. They're not partially blocked nor damaged or cracked. Sometimes we have vegetation that grows up in between them. So it's good to inspect those on a rainy day as often as possible. We have some shoulder drains here. Here's a nice example of one out here. Hopefully that water is getting off the road and getting down to where it needs to go. Here's a median shoulder with a drain outlet, and this is not a guardrail class, but I do want to touch on something while we have this cable guide rail or guardrail up here, depending on what your state refers to it as. Oftentimes, when we talk about cleaning back the area, we've talked about making sure that it's free of debris and vegetation that may block or the flow of the water. So what we'll often do is come out here and we'll spray chemicals and such to clear back this area. One thing to be mindful and careful of when you come out here and you're spraying chemicals, over time that actually weakens the soil that's around these posts. And even though you may not physically be able to tell it with your naked eye, those posts are not mounted as well because that soil is loose. And if a vehicle goes off the road and hits the cable guide rail, it may not function the way that you want to do. So please keep that in mind when you're doing your maintenance work around these cable guide rails or guardrail, that we're not destabilizing the soil too much, whereas this will not function the way that we need it to. Depending on the state that you're in, you do not want to exceed how much space you have between catch basins. Some states have 400 foot as their maximum spacing. Other states have different ones. Make sure you consult with your engineers just to make sure they're at the correct spacing. In a vertical sag location, it's a really good idea to have more than one catch basin because we want to keep that water from ponding. And if one of those inlets gets clogged, that water is going to come right out onto the road. So oftentimes we'll put more than one catch basin to kind of help reduce the potential for that ponding. Or if one gets clogged, there's still one that's flowing. We talked in our first webinar, make sure the joints are sealed properly, the road joints, the gutter joints, just to make sure water's not getting into our subbase. We're keeping that away as best we possibly can. Here's some spacing between basins. That's a good spacing because what one basin doesn't catch, hopefully the next one will. And again, our goal this entire series of webinars has been capture the water, get a hold of it before it actually makes it out into the highway area. And to that point, we have some more basins that are connected up here, and we actually have a third one out here. And the idea is we are defending the road. We are keeping it from ponding or for the water sheeting across the road and thereby creating a hydroplaning issue for the motorists, especially coming around curves when they are not able to see what's coming. If there's water pooling or standing right there, they're going to run right through it. So let's help the motoring public as best we can to keep this from having taking place. Now, again, still part of a drainage course, but I do want to touch on this. We have bicycle safe grates that we put down. And just to let you know, the reason we put down these bicycle safe grates is exactly what it says. Well, bicycles tend to run over them. We don't want bicyclists catching their wheels into the grate. And that, number one, that begins a tripping hazard, it's a falling hazard. And unfortunately, in our country, one of the items in pedestrian and bicycle safety are traumatic brain injuries. And this could be a potential for someone to suffer one of those injuries. So we make sure we use bicycle safe grates. By the same token, and again, this is not an ADA class, but be thinking about this when you're looking at your items. You want to make sure that if a person is walking, let's say with a cane, and they're tapping that cane, that there's no potential for that cane to get wedged in those areas in the grate. If that happens, that's a very serious tripping hazard, especially for those that need a little more help. So let's make sure we don't have these too wide. It's very important, not only for on the pedestrian side and on the bicycle side. Together, they work as part of our drainage system. Here's more than one catch basin and a sag vertical. Again, that's a long drop. So we have not one, but we have two to help collect as much water as we possibly can. I want to talk about some of the old designs on the catch basins, on the inlets. And I say old design because you'll still see these type of designs out there depending on where you are. And again, we're not going to spend a ton of money coming in and pulling all that out and retrofitting those typically until it's a necessary design that we need to undertake. But this is the old inlet design. But what happens, and you can see where there all this cracking taking place, and the pavement needs help. What happens when we go and we resurface this? Well, what can happen? Well, unfortunately, if we're not careful, our catch basin could end up looking a little something like this. And hopefully you can see that very well. What they did is they came in and they resurfaced the pavement, but unfortunately, there's very little opportunity for water to make it into that catch basin. So what do we have to do? Well, you're going to have to come in and cut this out, and so that the water can flow properly. You may actually fix the older inlet design at that time, but you're going to have to do something to keep that water flowing and getting where it needs to go. This probably is something everyone on this call has seen before, and those are catch basins that have a whole lot of dirt, whole lot of soil, whole lot of grass in them. And this is not something that sprang up yesterday. It's been growing for a while. It is critically important that we do our maintenance as often as possible and keep up on things as best we can, because as these things begin to back up, water is not going to flow into that, obviously, but where will the water go? Well, the water is going to go here, and then it's going to go out, and it's going to go around. And again, it may end up back over here, but the problem is it's going to end up on the pavement. And you can already see a little bit of cracking taking place there. And it's also a ponding hazard, a hydroplaning hazard as well. So routine maintenance, very, very critical. Now, this is especially true around the fall, because you end up with situations sometimes like this, where a well-meaning homeowner has stuck all of their leaves, all their little twigs, all their dirt into the catch basin. I can't tell you why they thought that was a good idea. I can only tell you experience has taught me this happens more often than I really want to think about and admit. And so what happens, we have to come in and we have to clean this catch basin out, whether we're using a vacuum truck, whatever it is, we have to clean it out so the water is going to flow properly into the catch basin. Now, I showed a couple of slides ago, there was a resurfacing that took place, and it limited the catch basin's ability to collect water. But let's say there's new construction going on or some type of resurfacing going on. We run the risk of the catch basin area looking a little something like this. Okay, they came in, they busted up the concrete there, but unfortunately the concrete got pressed back up into the catch basin area. When we're out looking at issues and problems that we're really charged with doing, because we want to make life easier on ourselves, but also better for the traveling public, keep an eye out for these types of things in construction areas. We want the water to flow properly, especially in a rainstorm, to get off the road as best that we can. We need to clean that out. Certain areas tend to flood more, especially in new construction areas where there's no drainage set up. Oftentimes we'll see signs, left lane closed due to water or whatever. Make sure that in construction areas that you are keeping an eye on the maintenance and the water's flowing the way that it needs to. Here's some drop inlet maintenance, and you can see hopefully the water's getting to where it's supposed to go. But what we want to have happen is we want to clear back this debris. We've got a stick, we've got a post here, we've got some straw and some debris right there. Get that cleaned back as best as you can. Because what can happen over time, maybe not with this picture, but our drains will eventually not function the way that we want them to. In fact, oftentimes I've seen things where like that, we have the water flowing down, but then the water cannot make it into the drop inlet because there's too much debris around it. Perhaps we'd have an issue like this where the water's supposed to flow and then you have a massive drop right here. I assure you, no water from here is ever going to make it to that drop inlet. We need to make sure that we build this area back up, that we grade it, that we get compaction, that it's smooth, and the water is able to flow to the actual drop inlet. It does no good to have this out there if the water's never going to make it to it. Here's another example of a drop inlet. It's just not functioning the way that we want to. Again, you want to make sure you clear all this back so the water is able to flow properly down that paved flume to get to the drop inlet. And again, we talked about just a few slides ago about when you spray herbicide under the cable guide rail, you want to make sure that you don't do it over long periods of time because that gets destabilized. And if a vehicle hits that and that gives at all and it pushes into this area, it can cause some major issues for the motorist. So we want to make sure that we're being conscious of what we're putting out there. Now, let's play a little game of hide and seek. There is a drop inlet in this picture, but I want you to look at it, and obviously I can't see your response, but just take a moment and with your finger, I want you to point on your screen where you think the drop inlet might be, because there absolutely is one there. So just take a second and look around in this picture and just kind of think where it might be. And once you've done that, let's go ahead and look and see when I pulled it back a little bit, where the drop inlet actually was. And there, I pulled back just enough so we're able to see where the drop inlet actually is. And is that a major problem? Oh, I think it's a very major problem because that water is not flowing anywhere but over the top of it. So we want to make sure when we're looking at drop inlet maintenance, when we're doing our rainy day patrols, when we're identifying where our inlets are, make sure that they're open and free and clean to do. Here's some more drop inlet maintenance. We've got some high water or some high vegetation here. We want to make sure the water is able to make it to the drop inlet entrance, and we want to get that cleaned back as best we can as well. Not just drop inlets, not just catch basins. I want to touch briefly on junction boxes and maintenance. Here's an example of junction box. We want to make sure these things are free and clear of debris. We want to make sure they're free and clear of animals or critters, you might say. So make sure that we keep these open and clean to the best of our ability. Here's another one sitting right by the roadway there. Again, a little bit of the older design, but it works. We just want to have as much opportunity for water to infiltrate that area as possible to get where it is we want it to go. Here's another junction box. We could probably clean that up a little bit so that the water is able to flow freely the way that we want. Now, having looked at junction boxes, I want to talk really briefly about box culverts. And I want to point this out because I think it's really important. Routine maintenance of your box culverts is just as important as if you're looking at pipes and as you're looking at ditches. If there's some type of drop off at the end of a box culvert, it's usually tied to the fact that there's some erosion around the outlet, and we'll talk a little bit about that here in just a minute. And this is one I want you to underline. If you have the printout, I want you to highlight it. I want you to put an asterisk beside it. We do not use riprap in live streams. What does it mean that we do not use riprap in live streams? Well, you remember, if you were with us on Thursday, we talked about riprap and rock check dams and using rock so the water flows through the stone, through the rock, but the rock is able to block out the impurities, the silt, the sediment, the dirt, whatever it's pulling with it. When we place riprap in a live stream, we run the risk of that stone or that rock being carried by the live stream down to our piping, down to our inlets, down to our basin. So we want to make sure we are not putting riprap in a live stream. If we have riprap in an area and there's a live stream coming through, we need to get that out as soon as possible. Again, box culvert maintenance, we want to make sure they stay clean, they stay clear of debris. Depending on the area that you're in the country, there may be critters and such up in there. Please be very careful when you're talking about box culvert maintenance. Be responsible. Be very, very careful and be mindful of your areas. And again, that may not be confined space required because it's pretty open. But that also means you can get some bigger things in there. So please, as part of your safety, I know you're wearing your PPE, your personal protective equipment, but just be mindful of the areas that you're stepping in and what you're doing. Again, here's another example. It's just some box culvert maintenance that needs to be done. Again, we've got a lot of water flowing through there. I want water flowing through there. Remember, we want to get it away from the roadway as quickly as possible. If we can't intercept the water, at least get it away from the roadway as quickly as we can. I want to touch on in treatments. They're very important. In guardrail, we understand we put in treatments on the end, very simply put, because if someone hits them, we want to make sure the person survives. They don't get speared. On the drainage side, when we put in treatments up, there's a little bit different reason for what we do. We use in treatments when we need to stabilize the slope that is behind a pipe end. And and I'll put this out to everyone. Go ahead and answer in the chat box if you would. What might be some of the reasons we need to stabilize the slope behind the end of the pipe where the pipe is sticking out? What might be some of the reasons we need to stabilize the slope area? So I'm going to step away for a moment. If you'll go ahead and start typing your responses.
They've put in prevent scour, erosion, landslides near edge of road, pavement infiltration to avoid water undermining the pipe, to avoid settlement, scour prevention, lack of right-of-way to allow proper slope, end of water flow, filling head wall, control slope, and control speed of drainage, hold roadway in place, slow down outlet water.
And all of those are excellent answers, and they're all correct. I want to add one more to it, and if Victoria, if you read it, I do apologize, but I don't think I heard it. Is oftentimes when we're at very tight turning radiuses and we have larger vehicles making right-hand turns, oftentimes the tires go off the road. We call it off-roading. Well, if you don't have that slope stabilized behind the pipe and those vehicles are able to run over that slope day after day after day, that's going to push that slope down. It's going to make the pipe less secure. So that's a good reason to use an in treatment. However, we're going to talk about when that can also be a problem in just a moment. When we talk about in treatments, flared wing walls tend to be the most efficient for stream hydraulics. I am not a hydrology engineer, so please don't freak out that we're going to go down that route because I'm not able to do that. But what I will say, we'll look at a picture and I'll explain why it tends to be the most efficient way to get your water out of the pipeway. And I said up here about vehicles off-roading, going off onto the slope. And here's the reason why. When we put in treatments up, it can be a problem because if we put a head wall in an area where a vehicle is likely to strike or it's a reasonable possibility, we may have created for ourselves a fixed object hazard. And what is a fixed object hazard? It simply means there is an item in an area inside the clear zone that's going to allow that if a vehicle hits it, it's going to strike it and it's not crash worthy. And we use the term crash worthy a lot in our work zone classes. When we say crash worthy, we talk about things that are meant to be hit and to give. Our signs, our channelizing devices, our cones, drums, barrels, all those things are considered crash tested, crash worthy. When we talk about wing walls, they're not really crash worthy. I mean, they'll take a crash, but unfortunately, that's going to do damage to the vehicle, which is not what we want to have happen, especially putting the motorist, their life in jeopardy. And then we're going to talk about a pipe end might be made safer by mitering it. Maybe we bevel it. And then we're going to look at what are called vehicle safe grates as well. Again, this is a mitered end. We talk about mitered ends. You can tell if you stuck that pipe out further, it would be very difficult to get coverage based on that area. So what we do, we come in, we miter that end, we cut it so that we have less need to have a bunch of fill and compaction. Okay, we don't have a lot of room there, but also notice water's still going to flow out of that. instead of it being rounded, it's going to flow in a little bit different way. It's going to move a lot. We still have to worry about scouring or erosion right here where the mitered end of the pipe, in this case, a concrete reinforced pipe, meets where the soil is. But that's one of the things that you want to look for when you're doing a rainy day patrol or some form of an inspection. We spent a lot of time on the very first day talking about lateral ditches. And again, we have an example right here. And it may seem counterintuitive to some. Why is it so important that maybe we have a grate over here on this inlet where the lateral ditch is? However, understand the guardrail, it flares right there and then it stops. So if a vehicle were to leave the roadway and head this way, we want to have a grate over it to make sure that vehicle's tires do not get stuck in it. It may cause that vehicle to roll over. It is possible, depending on the slope of this, it could cause a vehicle to potentially vault, depending on what type of vehicle it is. But this is what I mean by vehicle safe grates. The vehicle runs over it, it's not going to cause the vehicle to get caught anywhere between the slats there. Here's another median. We have a cross line pipe. What is a cross line pipe? Well, it basically goes across the roadway, and they put something over it to kind of just be safe in case something were to drive over it. Again, I would hope no vehicle made it out there, but as everyone is fully aware, things do happen. They happen very quickly. We talked about flared wing walls. Here's an example of one, and I just want to take a minute or two on this. You can see that's a very large reinforced concrete pipe. That's excellent. It's rounded. But notice, instead of just leaving the pipe rounded out there, and this is the term that's up there, they flared them out to the side. And the reason that they flare those out to the side is as the water rushes through, especially if there's a lot of volume that is coming through in that waterway, it's not just going to hit here and then stop. It's actually allowed to here and then flow out to the side. So hopefully the water doesn't back up. And those are really good. And you can tell they've got riprap, they've got stone around it. That's a really nice setup. But here's where fixed object hazards come into play, especially if you're dealing with any older designed of these, and it may look a little something like this, may not look like that in your area. But the reason that these become fixed object hazards is because those, whereas this one's a little tougher to hit, and again, we can't see the roadway exactly, we can see here that if a vehicle goes off the road and it were to strike that reinforced concrete, it's definitely going to do damage to the vehicle. Now, when we hit crash tested stuff, it can still damage a vehicle. That's not to be avoided, but there should not be fear by the motorist of losing their life. You hit this thing going really, really fast, that could cause a severe problem. So again, this is the old design, and unfortunately, this creates a bit of a fixed hazard object. We want to address that if we can and as the budget allows. Again, here's just a basic head wall. All right, it's not the flared wing wall, so this means all you're going to have is the water flowing through the rounded pipe. And there is the potential, even though you have riprap, you have rock on either side, that water might back up. And that's the difference with why the flared wing wall may be better for getting a large amount of water through as quickly as possible. We go into neighborhoods, you see a lot of these driveway pipes and these head walls in there. Again, how much water are we moving? I don't know. It depends. But you need to make sure the water is flowing, and then you need to make sure this ditch area is the right shape, so it's going to move a good amount of water, hopefully down through the next driveway pipe until we get it to where it's going to go. When we talk about appurtenant structures, and what are appurtenant structures? Well, we use them to maybe improve what our drainage is doing, or maybe we have an erosion problem and we want to be able to reduce how much erosion that we have. We use energy dissipators for appurtenant structures. This is where we talk about using riprap. And the reason we often use riprap is not just to stop the soil or the dirt from taking place, but also it's going to slow down the flow of water, especially in places where the velocity is really, really high. Water's flowing and it's flowing hard, and it's going to cause erosion. We will put riprap in there to slow that water down. Again, not just because we're worried about what's getting into our catch basins or into our drop inlets. We're concerned about how fast the water's going. And if it causes erosion, all that work we have up here is for naught, because the water's never going to get where it is we want it to go. We use funnel drains sometimes to collect surface water, especially on roadways that become what are termed high fill sections. In other words, there's a lot of water taking place and there's a lot of water moving through. So we will use funnel drains to help with that as part of our drainage system. Here's just an example of a silt basin. We have the water being captured right here. And if that's not something you use, maybe might be a little more familiar with a silt basin that looks a little something like this. We talked about riprap channels a whole lot. And again, if this is a live stream, we want to get that riprap out of there. This doesn't look like there's a live stream going on. What it looks like is you have the pipes coming here and the water's flowing and then it's forcing the water through the riprap. That's perfectly fine. It's not a live stream. It's not carrying our riprap anywhere. We don't have to worry about that issue. It's okay for that riprap to stay where it is. Now, once the drainage is done, if we're not expecting water to flow through that area, go ahead and get that riprap out. You don't need it there because depending on how close the roadway is to where that riprap channel in, that can become a fixed object hazard. So you want to make sure we get that out if it's no longer being used or if it's no longer necessary. Again, we talked about funnel drains a couple of slides ago. These are excellent ways to get water off the roadway, especially on high-speed roadways where you expect a lot of water to accumulate in a storm. Depending on where you are, you may have those microburst storms, those flare-ups like we have where I am, and they'll just pop up and they'll blow very hard, almost hurricane-like for about 5 minutes and drop a whole lot of water, and then poof, it's gone. It's sunny again. So if you anticipate there's a lot of water that can accumulate and be dropped, go ahead and put those funnel drains in. Those are excellent. And you saw this in the last the slide before, but these temporary slope drains, that's what this is showing. They're temporary. They're not meant to be long-term, but again, we're getting water through and then we're pushing it down through the riprap that is there. It's also possible to use a paved flume. When I think of flume, I think of my favorite place in the world, which is Disney World in Orlando, which of course none of us can go to, but they have the Splash Mountain flume, and this works just like Splash Mountain. You get to the top here, then it's going to move down very quickly. That's where the water goes, and hopefully get it off the roadway and out to the catch basin and as far away from the road area as we can. Again, here's a good example. If you can get the water to flow down and away from the roadway out here, that's a good use of an appurtenant structure because you're getting the water out towards the vegetative area, the natural areas of the roadway. Here's an appurtenant structure where we've got water pooling. It's ponding on the road, but it is flowing off onto this appurtenant structure, off onto this paved flume, so we can get the water away, hopefully, as quickly as possible. Some people have actually used a paved ditch to a lateral ditch. That's fine. Again, the concern is get the water off the road, get it out to that lateral ditch in that vegetative area. So these are good examples of some drainage components and systems that are working. But here's one that may need some work, and that is slope drain maintenance, because we've got a slope drain out here, and that's pretty good an entrance area. That's a good sized mouth, but the problem is if the rain and the water comes here, it literally has to go up that little embankment up and into the slope drain, and that's really not how it's going to work. From a hydrology standpoint, that's not how water is going to flow. So we have to somehow figure out a way to build this up, get this graded properly so the water, when it flows, will flow directly into the slope drain. Otherwise, it's meaningless to have it out there if it's not functioning properly. And that leads us to inspection, which is the last part that we want to talk about. And when we're talking about inspection, there's a couple of good times during the year to do that. In the springtime, when you're getting showers, in the fall, when you're getting showers and the weather's changing, leaves are falling, that's a really good time to do your inspection. Or if you have a heavy rainstorm, if you have your 5-year storm, your 10-year storm, or God forbid, and I already saw there's one out just off the coast of Florida, has a 50-50 chance of developing. If you're in an area where tropical storms like to come visit and hurricanes, you want to make sure you are checking and making sure, because when those storms hit, it's difficult, almost impossible for our systems to hold that much water. But if they're blocked and they're not flowing properly now, it's only going to make things worse. So you want to make sure you get your inspection in, not just in the spring and fall, not just after heavy rains, but as often as you possibly can. What are some of the results when we're out inspecting? Well, we may see the roadway has some cracking on it. We call it alligator cracking. That's what I've always called it. Maybe the subbase, all right? The area that the road is built on, maybe the subgrade, maybe there's water that's infiltrated down into it. And now the problem is there's cracking happening underneath because as the traffic goes over it and it's pressing down so hard, as that subbase and subgrade is shifting and giving, and it's moving underneath, and that pavement that's being pressed down, it doesn't have a firm foundation to hold, and so it's going to start to crack as that water begins to wear away the soil that's underneath it. When we talk about scour the inlet, and we covered this on day number 1 and 2, if there's scour at the inlet, maybe we made that grade just a little too steep when we put that pipe in. What you don't want to do is have a pipe that's not the correct size. Maybe we put one in that's just too small to move the amount of water that is now going to flow through. Maybe we didn't align the pipe very well. Remember, we want to align our pipes with the flow of water, if at all possible. Maybe we put it in a bad spot, or quite honestly, maybe the pipe's just clogged. Maybe it's just not flowing the way that it needs to. Could be that maybe there's high shoulders that need to be addressed. Maybe that's the problem. So when we're out inspecting, we want to make sure we look for those areas as well. And when I talk about rainy day inspections, I mean something similar to this. You're out driving, there's not a whole lot going on, but you're able to go and see the areas in your city, in your town, in your county, in your municipality, or your state maintained area where you can see the water. Man, it's flowing out into the roadway. This ditch is backed up. We need to make a note of this and come back and say, what can we do to get this issue addressed? Now, this is a pretty extreme issue, yet it happens on a daily basis around the country. One of the more common ones that we see around the country as well is easily preventable, and that's by doing preventative maintenance, and that's coming in here and cleaning this stuff back. Get it pushed back so the water, when it flows, will flow to the grate as it's supposed to. We talked about bicyclists and grates and making sure they're bicycle safe. We talked about pedestrian safety, especially for those with ADA. This also can be a hazard for someone who is a bicyclist or has an ADA issue. You want to make sure that we have that area cleaned back for them. So again, it's not a tripping hazard. It's not something that's going to hurt anyone. Here's some curb and gutter section that really needed the proper slope put on it. What does that mean? That means if it's even and it's flat and it's straight, that water has nowhere to go. It's just going to sit. If that water is not sloping towards the gutter and section, the water's not getting where we need it to do. And as we've talked about uh, a whole lot, as that water sits, it eventually begins to matriculate and infiltrate under that pavement. And as we saw a few slides ago, the subgrade may get damaged, the subbase may get damaged. And when that happens, we're going to have cracking taking place on that roadway. Here's another example of some inspection. This on a state maintained highway. You can see there's some debris thrown out there. We see some pine needles and some other things out there. As that water flows, it may make it to that drain area, but it's not going to go anywhere. It's going to pull, it's going to back up, and it's probably going to end out in the roadway, and that's going to cost us an enormous amount of money over time to get this fixed. We need to be getting more out of our roadways, both at the state level, the county, the city, the town level, than we're getting. So we want to make sure we're doing as much preventative maintenance there as possible. We want to make sure we inspect our areas. Again, you have a right-hand turn. You can see where these have come loose a little bit. As it rains, it's a good opportunity for some of this debris to be washed out into the roadway or carried down into our catch basin. We don't want a bunch of that to happen, so we want to make sure that we're staying on top of those areas as well. Again, common areas that we deal with, standing water in the roadway is an issue that we do have to look at. And again, it's not just the damage to the roadway, it's the immediate damage that can take place if a vehicle loses control and strikes another vehicle, strikes a fixed hazard object, maybe they roll their vehicle. So we're not just keeping and maintaining our drainage systems, just keep water off the roadway because we don't want our roads being damaged. We have to think about the lives of the motorists as well. And sometimes we'll be asked in our work zone classes, well, it's not fair that I have to think about all these other things. Well, this is part of the job that we take on when we work in drainage. We're not just thinking about the roadway, we're thinking about the people on it, whether they think of us or not. It's our job to think of them and their safety, just as it's important for us to look out for one another and our safety as well. Here's some standing water Again, right at the edge of the pavement, I'm going to guess the shoulders probably too high, which means there's nowhere for the water to flow, which means we're going to have infiltration taking place. Over time, if you're not careful, you may see some areas that have some pools of water on the pavement. That can sometimes mean maybe there's not the crown on the road that we need. Other times, it could possibly mean that there's a depression because there was a settlement in a pipe underneath the roadway. So we need to consider that possibility as well. Again, one more example of standing water on the pavement. For larger vehicles, that may be a little easier to navigate, but especially as we have smaller cars, smaller vehicles on the roadway, there's a very good opportunity. We use the phrase, turn around, don't drown. Well, if you can't tell how deep the water is, you're liable to drive through it. So we want to get that water off the roadway as soon as possible. And to that end, I have a question I've been sitting on for the first 2 3/4 webinars. So I want to ask it now. I want you to weigh in the chat feature in the chat box. At what point does it become our responsibility as a public agency to address the water issues if it's from a private property, if it's from a business owner or a homeowner where water is flowing out into the roadway because something is blocked on their property? At what point are we allowed to step in and address that? Go ahead and weigh in with how your jurisdiction, your agency handles that. I'd love to get a little feedback on that from you if you don't mind. So I'm going to take a moment.
The
Victoria, if you'll
first
share the input.
person put in ASAP, and then the other responses are when it hits the street, after requests are ignored, impact to public safety. Once it's on our road, it's considered our water. When it hits the right of way, once water flows into the road, as soon as water begins to reach the street, when it affects the traveling public, when it violates the design standards, public handles first 100 feet of runoff from design. Our ordinance says no discharge into the streets, so right away. For the most part, they're all saying when it hits the road.
And from jurisdiction to jurisdiction, across state lines, that's been my experience as well. Now the challenge becomes, okay, it's hit the roadway, it's our responsibility because ultimately we're the ones that are held responsible for anything that happens in the roadway, again, fairly or unfairly. So at the point it's causing this type of issue, we as a local agency have to step in, deal with either the homeowner, the business owner, whatever area this is right here to get this resolved. And in some cases, it is at either the homeowner or the expense of the business owner. Again, that depends on what your local regulations say. The DOTs I've worked at and worked with, we could come in and we could repipe all this and do the work, but we required that you paid us for the machine use, for the labor, and we requested that money up front. We would come in and do it. If our resident engineer or our city engineer would sign off on that, we could be assigned to do that. You may be allowed to do that. You may not be allowed to charge the homeowner depending on where you are. That was my experience in the 2 states that I've worked in. It's always wonderful when our homeowners leave their leaves in the gutter line. Now, to be fair, there are some local agencies around me that they want their people putting their leaves out there in the roadway, and they're going to come by and they're going to suck them up with the vacuum truck. If that works for you, that's great. But if that's not something that you do, or if that's a huge expense for you, this can create a really serious problem for water flowing, because if we don't get this stuff cleaned out quickly, and let's say a rainstorm comes, oftentimes we end up with something that looks a little something like this. Maybe not exactly, but this gives us a general idea. And you can see that water is flowing, but it's hit a very large stack of leaves, and now it's just going around. And if that's the grade, or if that's the area, if that's the catch basin, the curb and gutter section where the water is supposed to leave the roadway, we've got a problem because the water hasn't met the roadway. And again, especially on curved roads, but it can be straight roads, narrow roads, insert whatever type of road you want based on your jurisdiction. It's a problem, and we need to get it addressed, hopefully as soon as we can. We talk about inspection. We can see the water's flowing pretty well. Yes, we have some leaves there, and unfortunately, leaves are going to get down there. We can't always prevent that, especially as the rain falls and it washes some of the loose leaves away. They're going to hit the pavement. You can see them hitting the grass. Unfortunately, this is part of life, so we are going to have to keep an eye on these when we're inspecting and make sure they stay cleaned out, because debris is going to get into it. Even on our best days and our best abilities, that's still part of what's going to happen. We referenced this last class, some state-owned property that has some issues over where I'm at. It has gotten a little bit better, but we still have issues with water coming out into the roadway. And again, shot from the other side coming the opposite direction, you can see there's a nice drop off here, and it's collecting a very large pond of water. And over time, we have seen that cracking is going to continue, and it's eventually that water is going to get underneath the surface and go further out. Here's some water that's standing on pavement, and this was just resurfaced not long before this. And that tells me if that was resurfaced and water's still standing like that, it's not going anywhere. It's very possible either you could have a clogged drain somewhere around here, but more properly, I think maybe not the crown on the road. The road is not angled to drain the way that it needs to, which means we've got to get people out there. We've got to resurface it again. And then we end up in an issue of, well, who's responsible for the pavement? Well, my feeling is if the contractor did it, the contractor should be responsible. But we have to deal with that as a public agency when these issues take place. Here's some standing water on the pavement, on the shoulder, flooded over here in the ditch area. That's a very dangerous situation as you have vehicles trying to get off on that right-hand lane onto that exit. That's very dangerous for them to drive through. That's not just a little bit of hydroplaning, that's pulling, that's some deep water that you have there. We want to get this fixed as soon as possible. We've got to get some type of drainage system or component in there that's going to move this water out of the way. They decided to put a valley gutter in this picture, which is okay. You know, the water's going to flow down that valley. The problem is they get to this point and there's that big old hole right there. If that were where the grate was, if that were where the catch basin was or the slope drain, that would be one thing, but it's not. That's just a big hole and the water's just going to go down and it's going to go underneath and we can't see where the water's going to go, but we can just imagine it's going to continue to erode either the slope on this side or get underneath the shoulder and the pavement right there. I did want to end with a positive picture. Here's a lateral ditch. It's been piped. You can see it's clean, it's neat, it's free of debris. I do believe that we can have these types of structures. I also understand we are working to do a whole lot more with a whole lot less people. So it's very hard to stay up on our inspections, but it's critical that we do, because if we don't keep a regular inspection schedule, it's going to cost us a lot of money. I don't know if you remember from the very first day we started this, we said for every dollar spent, it saves $4. So we want to make sure that we're spending the amount we need, but not exceeding it, because again, we're all taxpayers and we want to make sure we're being wise servants and using that money correctly. Last couple of slides here and we'll be done. Just kind of tie everything up, everything we've talked about in the 3 webinars to date. You want to make sure that when you're doing your ditch lines, you're not 12 inches above the subgrade, you're 12 inches below. We want that water below so that water is able to be free and filter away, not be right next to the roadway where it's just going to slope right down on top of it. We've talked about ditches, we've talked about curb and gutter sections, drop inlets, we've talked about lateral ditches, all these things. We want to make sure they're clean and free of debris as much as possible. When we're using grass lined ditches here, and this is a touchy one, because we want it to be free of plants and trees that would slow down the flow of water. You need to check with your supervisor and make sure if you're taking any type of plant life or anything out that you are approved to do that. Some areas are more strict than others. Make sure when you're driving around and you're doing inspections that you're checking to make sure the shoulder drains are working. They're assisting with the drawdown of water, because remember, we put those in areas that tend to have a lot of water flowing through or being dropped in that area. And again, this is simple, but it needs to be said. Make sure when we're out there and we're approving our roads and we're taking a look at them, that they have the proper crown on them. There's no ponding areas on that roadway, because if that is the case, then those subgrade areas, those base layers are going to soften over time, which is going to mean the asphalt surface, which is hard, does not have a firm foundation to settle upon, which means it's going to deteriorate more quickly. And when we first started this journey together, we said drainage, 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 drainage. But one of the foundations, no pun intended, of a good road is having really high quality materials from the area that you're in, but making sure that foundation is strong, it is even, and it is compacted very well so that you're able to keep that pavement lasting as long as possible. And with that, we look at our available resources, and we can see we've got the vegetative lining there, the water hopefully flowing from that roadway down that vegetative lining into an outfall ditch, into an area that's got riprap in it. Hopefully that water is going to flow through. You can see where there's some color right there where perhaps some soil and some sediment has been carried through. It's caused some discoloration on the rocks. That's really good. That means the riprap is doing what it's supposed to do, and we're getting that water away from the roadway, but also to a more natural area, perhaps to a high quality water, to a wetland, even to a swamp. We want to get those things away as soon as possible. And to that, I have a question for everyone here, and that is, we get a lot of phone calls, especially as local agencies. Farmer John needs this. He needs a new culvert placed under a roadway so his cattle can get through. Or Mrs. Smith calls because she bought a home right next to a swampy area and she wants us to drain that area because she's having trouble selling our homes. Perhaps you've gotten a call where there's a beaver on property and that's causing water to back up because they're building beaver dams everywhere. Now we've got water into the roadway. And there's various other situations that we have, but the one question I want to ask of you is represent your agency well when you're dealing with the public, because part of this job is public relations, whether we like it or not. And homeowners, business owners may not understand where we're coming from. They may be confrontational at times, maybe even agitated. We have to make sure we're being the best representative of our agency that we can. You know, my grandmama always told me you catch more flies with honey and vinegar, and it's hard, it's difficult. Sometimes people want to come into your work areas. Maybe you have that issue where you have pipes settled over here and you're getting ready to drop those in a pipe and people want to walk up and ask you, what are you doing? Well, maybe your response would like to be, I'm washing my hair. What does it look like I'm doing? Or we're playing a video game. What does it look like we're doing? We can't really treat people that way. We have to be respectful because we are representing not only our local agency, but all the leadership of the city, the county, the municipality, or the state, depending on whom you're with. So make sure we're using all of our available resources as we can. And having said that, I drew up 3 poll questions. Ms. Victoria, if you would ask those, we want to go over those real quick, and then we'll have a few minutes for questions before we sign off.
Absolutely. I put the first one out there. Riprap is used in a live stream, true or false? And while they're answering that, we did have a couple of questions that had come in, and it actually relates all the way back to the beginning when you were talking about the geotextile fabrics.
Okay.
Is the fabric wrapped around the stone, or is it just not shown in the image that you had up on the screen?
It is not shown in the image. We're not what we will do when we're putting down a geotextile is sometimes we'll pin it down with stone to hold it in place. But we are not wrapping it around a stone. We're laying it flat. That way we get better compaction over the top of it. We don't want to wrap it around because then the water won't flow through the way we want. And then you'll have water pooling between the pavement and where that geotextile is. And that's not what we want to have happen. So no, please do not wrap the geotextile around the rocks.
Okay, your question is complete. I've got the results up. 12% said true and 88% said false. And there were 5 people in the question box that said false as well.
Okay. And when we talk about riprap, the rock, the stone, we want to make sure, and I appreciate everyone who voted on that. Thank you for honoring me and participating throughout this time. We want to make sure that if the water is flowing through there and all it's doing is just catching the sediment and the dirt and is allowing the water to flow through, it's okay to have our riprap out there. But if it's a live stream that's flowing constantly, we really don't want to put our riprap out there, because what's going to happen is that live stream, especially as it flows heavy, is going to move that rock down. It's going to cause an issue where we're blocking our pipes. We're blocking our other drainage systems. So make sure we take out the riprap when it's no longer necessary, or when it's in a live stream. We're not allowed to put that rock in a live stream because, again, it's going to carry it downstream. And we have a poll question.
Put the next one up for you. Ready?
Yes. Thank you.
The flared wing walls are the most efficient for stream hydraulics. True or false? And they're almost halfway through voting right now. So
okay, all right.
Okay, we're almost there. They picked up speed. Okay, I'm going to close this poll and share the results.
All right.
3 people in the question box said true, along with the 95 who chose true through the polling feature, and 5% said false.
And when we talk about flared wing walls, one of the things to consider is when we have just the reinforced concrete pipe, the water's going to flow, not a question. But once it gets to the end of the rounded concrete pipe, where does the water flow? When we use the flared wing walls on the side, it allows the water to flow out, run along the flared wing wall, and still move water further out. So that is correct. Flared wing walls are the best for a hydrology stream. And again, I am not a hydrology engineer, so we're not going to go any further than that. But that is the best way for that ended pipe to get water, especially when you have heavy amounts of water flowing through. And I believe there's a third poll.
Yep, I've got it up already. So what
Sweet.
types of problems can reveal themselves on a rainy day inspection? Settlement failure near rock check dams, pipes not flowing fully, standing water on a roadway, or all of the above. And while they're answering that and getting the percentage up here, I have to share that there's this video phenomena out there on YouTube. I don't know if you've ever seen it, where people go out and just record cleaning out blocked storm drains and how quickly the water runs out. It's a crazy thing. My teenagers watch it. So.
I've not seen the video. I've lived it though, and you're absolutely right. It's amazing what'll flow when you unstop those areas.
Yep. Okay, we shared the results, and I had 4 people in the question box that said all of the above, along with 97% on the poll. 3% chose standing water on a roadway. So there you go.
And I appreciate it, again, everyone who weighed in on that. It is all of the above. Each of those things can be revealed when we do our rainy day patrols. And for the 3%, I believe, that selected the standing water on the roadway, that is a very important part. It is absolutely important to see, is that water standing? But when we're out there on the travel way, not only can we see that, we can see some of the other issues. Is the water flowing through the ditches properly, or is it standing? Is the water getting off the road, or the shoulders cut the right way? There's a lot of different things to see. But water standing on the roadway is very, very important. But actually, all those things can be seen, plus a whole lot more. I mean, there's a lot to this that our men and women deal with on a daily basis.
Well, Scott, thank you so much for the webinar today. I'm sure we're happy to take just a couple more questions if anyone has them, because we do have just 3 minutes left here.
Absolutely.
But it looks like it's just kudos rolling in for you right now, though. Everybody's saying thank you.
Well,
so,
like Bugs Bunny said in the Looney Tunes cartoon, me public, thank you very much for that. And again, if we can assist you in any other way, reach out to Victoria. I know if you have some ideas on other webinars you'd like to see in the area of drainage, please let her know.
Absolutely.
Do.
Appreciate it. And everyone stay safe. Have a great afternoon for both Scott and I. And we hope to see you again on a future webinar. Everyone take care. Thank you.